Welcome back. This is an Aleks training video on predicting bond polarity. So remember, you can share an electron pair unequally. So if you were going to have two elements that would share a bond equally, you might have something that looks kind of like this, where the electron is kind of in the middle, so it looks kind of like a jelly donut, where that they're kind of like that is going to be the same as that, and the electron is going to spend equal amounts of time in this one and this one. Okay, if it's being shared, it'll spend equal time. If it's unequally shared, you might have something like this, okay, like a chicken leg, where one element is pulling on the electron pair more than the other, and so it's spending more of its time in the right hand neighborhood in this case than the left hand. Okay, that's polar. Polar means where this side has more negative normally because there's the electrons hanging out there more, and if it's more negative on the left hand, then by just default it's going to be more positive on the left. This is polar. So this would be polar. This would be nonpolar. If it's sharing equally, it's not positive on one side and negative on the other side. There's no charge difference at all. So polarity is just a difference in charge, whether there's more charge on one side or not. And you will use the electronegativity, the same one that we talked about previously. There's a number assigned to every element of how much it pulls on a valence electron it's joined to by a bond. Okay, so we see that in general, the upper right hand corner of the periodic table is going to pull on electrons very strongly, and the lower left hand corner is going to pull on very, very not strongly, okay, weakly. So I can pick any two atoms, and if there's a bond there, I can tell myself, is there a more of a pull or less of a pull or equal pull? Okay. Now the kind of rule of thumb is if the difference between electronegativities is greater than 0.5, greater than a half, then it's polar. Okay. So, and if the difference between them, so you'll take the negativity of the one and the other, subtract them. If the difference is 0.5 or less, it's considered totally equally sharing. Okay, even though it might be slightly off, it's still considered okay. But if it's more than 0.5, you're going to most likely consider it polar. Okay, so let's look at the first one. I've got in this one oxygen and carbon. It's highlighted in red. So what is it saying here? The highlighted bond is polar and more negative atom is, or the highlighted bond is nonpolar. Okay, so the more negative atom is the one that has the higher electronegativity than the other. Okay, so let's look at these. You'll see this is actually an easy question, not as long as you know the electronegativities or can be able to find them. All right, so I've got carbon and oxygen. All right, so carbon here is 2.5, oxygen's 3.5. Take 3.5 minus 2.5, it's 1. Okay, so it's going to be polar. So this is going to be polar. And since it's polar, they want to know which one's more negative. Okay, it would be the oxygen. The oxygen will be more negative. So I would write in oxygen. Okay, how about the next one? Is it obvious? Does it jump out at you? I've got chlorine and chlorine. Which chlorine is pulling more than the other chlorine? They're pulling the same. Okay, if they're pulling the same, then it's going to be non-polar, like over here, like the jelly donut. They're pulling it the same. So I'm just going to say that it's non-polar. Okay, they're pulling with equal strength. What about hydrogen and chlorine? Okay, hydrogen, if you come over to hydrogen, it's 2.1. And the chlorine way over here is 3. Okay, so 3 minus 2.1 is 0.9. So 0.9 is going to be more than 0.5. So that's going to be polar. And which one is more electronegative? Obviously the chlorine, it's on the right, and the other one's on the left. Okay, so have no problem with you using your book for these questions, looking at a table. You're not cheating. Nobody in the world would memorize all these. Maybe somebody would, but I wouldn't. I'm not going to memorize a table when I can look at a picture. But you want to kind of know the trend that towards the upper right corner, it's going to pull harder than to the other. Okay.